These are notes for Honors Math 3. This is Unit 9, Objective 13 on inverse trig functions. So we'll be working today with all 6 trig functions and their inverses. And we're going to learn a little bit about the range of values they work in and what the notation looks like as well. So what we've done so far with inverse functions is learned that they're reflections over the line y equals x. And if we want to solve for an inverse function, we switch x with y and solve for y. And then we also know that because we're switching x and y, we're switching the domain and the range. So I'm going to start here by solving for the inverse of sine. So we'll let y replace f of x. Okay, in inverse, we want to swap x with y. So we'll write x is equal to sine y. And then in order to undo sine and solve for y, we introduce its inverse, which is called inverse sine. So one of the notations that we'll be using for that is arc sine. So we'll take arc sine of x and arc sine of sine y. So with any inverse operations, they simply undo one another and leave behind your y value here. So we have y is equal to arc sine x, which we replace y with f inverse, so this notation here. So that's our inverse function, arc sine. So besides arc sine x, we could write inverse sine the same way we wrote inverse of f. That is common on calculators, and we don't want to confuse it with the exponent -1. So we get that from just the context of the problem we're working on. Inverse sine x is the last way you might see that notation written. All right. All the other functions work the same, so inverse cosine, inverse tangent, and so on. So I mentioned that because we're switching x and y, we're swapping their domain and range. The graph of sine has a domain of all reals. And so if you take the inverse function and take a look at it, based on the entire graph of sine, it would appear its range would be all reals. But in that case, the graph of sine would not be a function. It would not be 1-to-1. And so in order for sine to be a function, the range of values is -pi/2 to pi/2. So we'll have arc sine x has a range from -pi/2 to +pi/2. And so does its reciprocal, arc cosecant. The only other function that will be grouped here is arctangent, except at negative and positive pi/2, arctangent doesn't exist. So if you think about tangent at negative and positive pi/2, that's where the asymptotes occur. So inverse tangent won't exist at those values. So we'll have the less than or equal to for these, and then just the less than signs here. So inverse sine, inverse cosecant, and inverse tangent all only work in quadrants 1 and 4. So this is -pi/2 to +pi/2, and we won't work in, pass through, or go into quadrants 2 or 3. All right. We're going to get something similar that happens with cosine secant and cotangent. So arc cosine and its reciprocal arc secant have a range 0 to pi. So 0 to pi. And if you remember, the graph of cotangent has its asymptotes at 0 and pi, and so it's grouped here as well. It just doesn't exist at 0 or pi. It works in the quadrants 1 and 2, never 3 or 4. All right, so we're going to be given values of the trig function, and then we're looking for the angles where those occur. So we are just solving problems a little bit backwards, if you will, of what we have been doing. So we'll do several examples here. All right, so in solving an inverse trig function, you have, instead of sine of an angle equals a value, it's just backwards. Inverse sine of that value is what angle. So this is really asking sine of what angle is going to give me the answer 1/2. So you'll notice that the number we're evaluating is positive. If you're working with inverse sine, all positive angles are in quadrant 1. If you have a negative value, you'll work in quadrant 4. The other 3, quadrant 1 with a positive, quadrant 2 with a negative. So you see all 3 here, sine, cosecant, and tangent, are positive in quadrant 1, negative in 4. And cosine, secant, and cotangent, they're all positive in quadrant 1 and negative in quadrant 2. So it gives a positive and negative for everything. So if inverse sine is a positive, we're right now looking in quadrant 1. So my answer should be an angle between 0 and pi over 2. I'm looking for the angle where sine is opposite 1 over hypotenuse 2. If it helps, you can draw it out. So quadrant 1, opposite 1, hypotenuse 2. That would leave the remaining side as root 3. We always have 30 degrees next to root 3. So 30 degrees, or in radians, pi over 6. And that's it. There's only going to be one answer for these problems. So number 2, inverse sine of negative 1 over root 2. So now you'll notice the number inside is negative for inverse sine. So we'll be working here in quadrant 4, which means my answer is between 0 and negative pi over 2. So my answer should be a negative angle. So we're going to draw it out. We know it's in quadrant 4. We want to label the sides for sine, opposite over hypotenuse. So opposite side, that's your negative 1, the hypotenuse, root 2. So these are side lengths that will leave you with a 1 on the adjacent side and a 45-degree angle. So 45 degrees or pi over 4 radians is your reference angle. But remember, inverse sine, if you're looking for an angle in quadrant 4, we have to move in the negative direction to get there. So although the reference angle is 45 degrees, my answer is negative 45 degrees, or negative pi over 4. All right, so these take some practice in getting used to, and we're going to do plenty more. So here is number 3. All right, arc cosecant of negative 2. So inverse sine and its reciprocal cosecant all work in quadrants 1 or 4. So this time it's going to be quadrant 4 because we have a negative value. So again, we can draw this out. If it helps, you can flip this around. So arc cosecant negative 2 would be inverse sine negative 1/2. So we want to do opposite over hypotenuse. So you can see that that would give me 2 over negative 1 or negative 2. That would leave the last side to be a root 3. And again, that would give me a reference angle of 30 degrees, or pi over 6. So the actual answer here, in order to enter quadrant 4 for an inverse trig function, for inverse sine or inverse cosecant, we have to move in the negative direction. So we're looking for this angle here, which is negative 30 degrees, or negative pi over 6. All right, inverse cosine of negative root 3 over 2. So when you switch to cosine, inverse secant, or inverse cotangent, you have to switch how you're thinking about these quadrants, and now you're working in either quadrant 1 or 2. The number inside is negative, so we must be in quadrant 2. So we're going to draw a ray in quadrant 2, bring it back to the x-axis, and label the side lengths. So I want adjacent, negative root 3, and hypotenuse 2. That leaves the opposite side to be a 1, and my reference angle again is 30 degrees. Now my answer must be between 0 and pi, and I'm in quadrant 2. So I'm looking for the angle that measure here. So we're 30 degrees before the x-axis. That would be either 150 or 5 pi over 6. So it just depends on if you're giving the answer in degrees or radians. Most likely we'll work a lot more with radians, but you'll just answer depending on if the question is asking for degrees or radians, and if it's not stated, then you can decide. All right, inverse tangent of negative root 3. So again, remembering the two different setups. So this is important that you can switch back and forth between them. Sine and its reciprocal with tangent, 1 and 4. Cosine and its reciprocal with cotangent, 1 and 2. So right now we're dealing with inverse tangent of a negative number. So we want to be in quadrant 4. And remember that the way into quadrant 4 is the negative direction. So we're looking for some negative angle measure. So in labeling here, we want to do opposite over adjacent to get negative root 3. So the opposite side is going to be negative root 3 over positive 1. Quadrant 4, positive x, negative y. All right. The hypotenuse would be 2. These are side lengths of a 30, 60, 90. So the reference angle here next to the 1 would be 60 degrees. But in order to enter quadrant 4 in this negative direction, our answer should be negative 60 degrees or negative pi over 3. All right. The next one here is inverse secant of negative root 2. Okay. So inverse cosine, inverse secant, inverse cotangent, quadrants 1 and 2. So everybody is going to be quadrant 1 if it's a positive. It's just remembering if it's a negative. All right, so this one is quadrant 2. Again, if it helps, like number 3 back here, we can switch and think about cosine instead. So inverse cosine, negative 1 over root 2. So adjacent negative 1 over root 2 here. So that's root 2 over negative 1 is that negative root 2. The missing side length then is 1. The reference angle is 45 degrees or pi over 4. And again, we're looking for this angle. So that is going to give us 3 pi over 4. So problem number 7 says secant of inverse sine of -1 over root 2. We want to work inside out. So we're going to start with inverse sine of -1 over root 2. Now we don't have to answer this part of the problem. We just have to answer what is secant of this value. So all that means is I might only need to draw my picture to find my answer. So I'm going to start with inverse sine of a negative is quadrant 4. We'll go ahead and label the sides. We want to do opposite, -1 over hypotenuse root 2. That leaves the adjacent side to be +1 and a reference angle of 45 degrees. So this would be an answer in here of -π/4. So that's not my final answer. I want to know what is secant of this angle. So secant of this -π/4 angle. So that is just evaluating a trig function at an angle. So once we do the inverse component inside, we're now left with just finishing this. So for this angle, -45 degrees, what is secant? So secant is the reciprocal of cosine here. So secant is going to be root 2 over 1. You'll notice it's positive because I'm evaluating secant of some angle that exists in quadrant 4. And in quadrant 4, secant is positive. All right, so let's try another one of these. Inverse cosine of sine of -π/6. So this is a little bit different. I'm going to start on the inside here with sine at -π/6. So this is not evaluating an inverse trig function first. We're just evaluating sine of -π/6. So if you want to draw it, we can draw it out. This is -π/6, -30 degrees. So this is root 3, -1, and a hypotenuse of 2. So sine of this angle is -1 over 2. So this becomes inverse cosine of -1 over 2. So now it becomes an inverse trig function problem. So inverse cosine of a negative means you're working in quadrant 2. So we're going to draw a new picture here. Quadrant 2. We label the sides adjacent, -1, hypotenuse 2. That leaves the missing side as a root 3. And your reference angle, 60 degrees or π/3. So we want to know what this angle is in quadrant 2. So from 0 to here. So 60 degrees shy of 180 is 120 or 2π/3. So that's what this comes out to. So on this one, we started on the inside and simply evaluated a trig function at an angle. We found the ratio of the sides to be -1/2. Then we did the evaluation of an inverse trig function. That is the part that we had to determine what quadrant we were working in. So inverse cosine of a negative is always going to be quadrant 2. All right. So we have just 2 more problems to try here. So this one says sine arc cosine of 2/7. So again, we're going to start on the inside here, inverse cosine of 2/7. So inverse cosine of a positive number, everybody's positive in quadrant 1. So we'll start with our ray in quadrant 1 and make a triangle with the x-axis. Cosine labels the adjacent over the hypotenuse. Now these are not numbers for a special right triangle. So not going to give us a 45, 45, 90 or a 30, 60, 90. And so all we need to know here is what is this missing side? And we can find that using the Pythagorean theorem. So we end up with the square root of 45, or 3 root 5. So that doesn't tell us what this angle is unless we had a calculator and we could evaluate inverse cosine of 2/7. So we're trying to evaluate this problem without it. So if all I had were this question inside here, then I would want to know what this angle is. Well, I don't need to know what the angle is because that's not all this question is asking. It's asking me for the sine of this angle. So what's the ratio of sine at this angle? So see, inside cosine of this angle is 2/7, the adjacent over the hypotenuse. Now it's asking us for sine of this same angle. So sine is opposite over hypotenuse, which gives us 3 root 5/7. All right, the last one here says tangent of arc cosine x/5. So we're going to go ahead and leave arc cosine in quadrant 1. We'll label the sides for cosine adjacent over hypotenuse x/5. And just like last time, we'll solve for that missing side. So we do not know what this angle is, but we'll take 25 and subtract x squared. And last time when we did that subtraction, we had a number and we could take its square root. This time we just have the expression 25 minus x squared. We would take the square root. Now that's not going to simplify anymore because the best we can do here is factor into 5 minus x and 5 plus x. And since we don't have two of the same thing, we cannot simplify it anymore. And remember, you're not allowed to square root each thing individually. So this is just going to remain as the side length root 25 minus x squared. And so now that we want to know what tangent is, well, tangent of this angle is opposite over adjacent. So our answer is root 25 minus x squared over x. All right, that is the end of your notes for Objective 13 and the end of the notes for Unit 9.